Welcome to XNT 302, Implementing Observability for .NET Apps on AWS. I'm Greg. I'm a tech leader for cloud operations at AWS. And I'm joined by my colleague Amaya, who is our principal solution architect for observability. So this session is a 300 level session, and that means we're going to go into code. We actually have 4 distinct demos. We're going to dive pretty deep into .NET code, into the console. So we'll have a short presentation. We'll get really hands-on, dive deep quite quickly here. So just a reminder, that observability is a very broad topic. There's a lot of things that we could talk about. We could talk about this for hours, but the focus of this session is going to be on .NET. The code that we're showing is going to be .NET. That being said, if you're using other languages like Python or Node or Java, the fundamental things we're talking about are going to be applicable to other languages. We obviously are just doing this from a .NET perspective. So at the end of this session, you should be able to confidently implement observability in your .NET applications running on AWS. We got a pretty simple agenda, 3 major areas that we're going to cover. We're going to talk about what is observability, why it matters for .NET, and how to implement observability for .NET. Please note we have a lot to cover here. We likely won't have time for questions. However, we're happy to answer questions after the session. So why does observability matter? And the first thing I would say, or I would put up here, is this image. This is why it matters. Observability matters because we want to avoid this look, right? When I look at this image, I see fear, I see panic. I see someone that doesn't really know what to do next, or what is the impact of this issue? How do I fix this? Observability matters because you don't want to have this look in your eyes when your system goes down and you're not sure what to do next. Monitoring, if we talk about monitoring and versus observability, monitoring is just what you do to collect your signals, your metrics, your logs, and your traces. Observability is a property of a system. It's going to help you better understand what's going on inside your application, inside your workload here. So observability matters fundamentally because we want to avoid this look. We don't want to be panicked. We want to understand what we should be doing next and how do we fix issues. There's also some challenges to some technology transformation trends that have created or have made it more difficult to monitor applications, right? Let's face it, your old school ASP.NET Framework monolith was fairly easy to monitor. You had IIS, web server, you had SQL Server. Microservices create much more chattier systems. There's lots of communication going on. And as you break down that monolith and move to microservices, it's much more difficult to understand all the moving parts in the system here. We also have polyglot applications. Obviously, we're focused on .NET today, but it's very common for folks to have some Java, some Python, some .NET. And so these multiple languages actually create more difficulties in trying to be able to monitor and observe everything here. We also have much more ephemeral environments. So as we're using serverless or containers, years and years ago, your servers could maybe, you guaranteed to have them for several months, if not years. Now we are dealing with environments that might only exist for a few minutes or a few seconds. So what happens to the things like logs and metrics that are on those servers when those resources go away? You need to make sure that you're still capturing those signals. And cloud native applications are also, tend to be more difficult to observe. When you're dealing with a monolith on a VM, it's much easier to capture all the information, all the signals that you need, versus cloud native applications where you're abstracted from a lot more here. So when we dive into observability, we need to also talk about the life cycle of an issue, right? Because ultimately, that's what we're trying to do. We're trying to avoid issues, and we don't live in a perfect world. We're going to still encounter those issues, but we need to make sure that we get through those, resolve them quickly and efficiently. And so the first step of the life cycle of an issue is the detection, and then we go into the investigation, and then we go into the remediation. Now, this is obviously very high level. I'm going to break this down a little bit more into what do we see if we actually take an issue and break down its timeline, right? So the first thing that we see here is this detection phase, right? And you'll see these MTTR, MTTI, and MTTD. These are just acronyms for the mean time to recover, mean time to investigate, mean time to detect. So we have our detection phase. This is typically an alarm. Hopefully it's not your customer phoning you or emailing you saying there's an issue. So hopefully you have systems in place, alarms, synthetic testing that will tell you there's an issue. Then you go and you move in. Once you've detected an issue, you move into the identification phase. And so this is where you spend most of your time. This is where it's really difficult. This is the most difficult thing within an issue, right? You can detect that there's something gone wrong, but you're trying to identify what is the scope, what is the impact, and what is the issue. And once you actually figure out what the issue is, the fix is usually pretty quick. And it's the same thing with verifying that fix. But it's the identification process during an issue that is really, really difficult. And this is where observability can really help reduce the amount of time that your system is down, reduce the MTTR. Because the identification is where you spend most of the time. And if you have a very complex microservice-oriented architecture, a bunch of chatty things going on, it's really difficult to understand what's causing what upstream is causing something downstream to occur here. And so the area of the focus today in this session is going to be really on that detection and investigation. So let's go into the introduction. I've just explained why observability matters, why it's important. Let's talk about observability on AWS. And the first thing I would call out is we do not have enough time in this session to go over all our capabilities on AWS around observability. The purpose of this session is to dive deep into code and the implementation of observability. But there is a fantastic workshop that Amaya has built with several other folks at AWS that will give you a fantastic demo of how these tools work. So we're focused on how you implement this, but if you're curious on how, once you've implemented this, what tools are available for you, I highly encourage you to go to observability.workshop.aws. There's a sample architecture diagram here that shows a relatively complex app, has some containers, has some VMs, has some serverless functions. So there's a little bit of everything here. It's already instrumented for you, and you can go ahead and use the tools and understand what tooling that we provide for observability here. So please, take a screenshot of this, just bookmark it, and go back to this after the session. It's a fantastic resource. But we're here today to really dive into how do we actually implement this. So to talk about those implementation details, we need to talk about three signals, the three observability signals. There's metrics, there's logs, and there's traces. And none of this really should sound too different, or you probably have heard about metrics, logs, and traces. Obviously, metrics and logs. Traces are a little bit different, that they're more user-centric, right? A metric or a log is capturing a signal from a component, from a server. A trace is really capturing the information from the user perspective. So as a user goes through a system, a trace is combining all those steps through that system here. So what is the life cycle of a signal? And this is where we're going to dive into this quite deep in terms of the metrics, logs, and traces, but it's the instrumentation. This is where the signal starts. If we don't instrument, we never capture the signal. So we have to instrument. And we'll show you how you instrument logs and traces and metrics, and there's slightly different ways to do those, and there's multiple ways you can do them. But this is where it starts. Instrumentation is where everything starts for the signal. And so we instrument and then we capture. And then obviously once we capture this, especially if it's on a container or a VM, we also have to transport that. In many cases when you're using serverless services like Lambda, we're automatically going to do the transport for you. But you have to instrument, you have to capture, you have to transport. And then obviously we need to analyze and use this data, use these signals to observe what's happening in the system so we can get out of that issue and get back to a good place within our application here. Now, the scope of this is really going to be on these first three steps. We'll touch lightly on some of the tools that you can use to analyze, but the last step here would also be the act. Like we need to actually take action on the stuff that we've observed and make sure our application is running well again, and we're past that issue. And there's basically two ways to do instrumentation, and we'll cover both. There's language-specific SDKs that you can use. We have a series of SDKs for different languages. Obviously, we'll focus on .NET today. And then we also have runtime agents that you can use there as well. And those agents are typically also used to transport data to AWS. You can also use our SDKs, especially in the case of logging, just to send stuff directly to AWS as well from your application. So you have that choice. And then we're going to have a series of dashboarding tools and analysis tools that you can use to actually monitor and understand these signals. Again, we'll touch on that very lightly. I highly encourage you to use the workshop to dive deeper into that. And then you obviously take your signal, you want to create some sort of mechanism where you alert, and then you send notifications. So how do we do this for .NET apps? How do we implement observability for .NET apps? So there's a bit of an eye chart here, but the focus is going to be on these three things: the CloudWatch metrics, X-ray traces, and CloudWatch logs. What you'll see here is on the left and right-hand side. On the left-hand side, you see our native capabilities, right? So things like App Insights, Lambda Insights, CloudWatch Service Lens. And on the right-hand side, we see our open source capabilities. So like Amazon Managed Grafana. And then within the middle here, you have these areas of these other services that will collect metrics, logs, and or traces here. But we're going to focus on the native capabilities in the session, and those are going to be, again, CloudWatch metrics and logs and X-ray traces. So we're going to dive really deep here and do several demos. So we want, the foundation for observability is like I said, those three signals. And we say you need to instrument all the things. You want to instrument and capture as many metrics, logs, and traces as possible. This is really key here. And so how do we get started? That's the question. The whole session is based on how do I actually implement this? And the way I would approach this, especially as someone, as a .NET developer or engineer, is you have two choices, and you're not picking, these are not one-way doors. It doesn't mean if you go down one of these paths, you can't use the other. But the best way to think about this, the mental model that you should use, is that we have CloudWatch Application Insights, and we have a do-it-yourself method. Now, you can start with App Insights, and then you can do some other stuff. You can do it yourself on top of that, so you're not just picking one of these and not being able to use the other. But we're going to approach this first from CloudWatch Application Insights. I'll show you how it can be used to really quickly do this instrumentation, this collection of signals, and then we'll go deeper into what if you want to do this yourself or you want to get much deeper here. So let's go ahead and actually take a look at CloudWatch Application Insights. So App Insights is basically, and this is a sampling of the services it supports, but it natively understands your application workloads. And so it basically is using something called the Systems Manager agent. And when you put that on your container, you put that on your EC2 instance or even on your on-premise instance, that agent is going to understand and basically guess at, hey, this looks like an IIS.NET web-based application. This looks like a Java app. And it's going to make some recommendations on the type of metrics you should collect as well as the logs. So App Insights, again, this is a sampling of the services it understands. But just think of it as a service or a feature of CloudWatch that helps you get started really quickly. And so some of the features of App Insights are the fact that it will automatically monitor workloads for you. It will automatically set up the instrumentation and the collection and the transport of those signals. It will do problem detection. So it will look both from the AWS resource level as well as deep into the operating system and your application and try and detect problems. And it'll actually do troubleshooting as well. I'll show you more details about those problems here. And when you're using App Insights or Application Insights, there's three concepts you want to be aware of. There's the component, there's the observation, and the problem. So the component is an auto-grouped standalone or custom grouping of similar resources, and there's different ways to do this. And I'll be showing you one way using resource groups, and then we have our observation. So this is just like an individual event, maybe an anomaly in a metric or a log error that's detected. And there might be multiple observations that may be aggregated up, and then App Insights will say, you know what, based off of these multiple observations, we believe we've detected a problem by correlating them. And so App Insights will classify and group those related observations together and tell you problems it's identified in the application. So let's go into our first of 4 demos. I'm going to go into CloudWatch Application Insights and do a quick demo of how you actually get started really quickly collecting these signals with App Insights. All right, so let's go ahead and proceed, and I'll do a demo of CloudWatch Application Insights. So what I have here are two EC2 instances, a web server and a SQL server. So the web server is IIS, SQL Server is SQL Server 2017, and they're both running Windows Server 2019. So I've already pre-installed that software. So you can configure CloudWatch Application Insights to automatically discover resources. I'm going to show you the resource group route, but it is possible to have this set up so it'll just automatically, if the agent has the SSM agent, the Systems Manager agent installed, it'll just automatically start it will monitor workloads automatically for you. But we're going to show you more of the resource group route, which is traditionally how you would set this up. But you have both options. So I'm going to go to resource groups. I'm going to create a resource group. We're going to do it tag based because I didn't use CloudFormation to spin up those EC2 instances. If I did, I could use CloudFormation as a way to group together these resources. But in this case, I have tagged my application with a name called app name, and I can click preview, and you'll see they'll bring in EC2 instances, network interfaces, as well as EBS volumes, and it has those tags there. So this looks good to me. I'm going to go ahead and name this demo app as my group name, and I'll go ahead and click create group. And so now this is just a logical container, a logical grouping of resources. Now that I've set this up, I can go back to CloudWatch, and I'm going to create a new application, click add an application, and I'm going to do it based off of the resource group. Again, I can choose to do an account based as well as, or I'll just simply create an app using all the resources it finds in this account. But I can be more explicit and say, choose the create the application based on the resources I've already grouped. So go ahead and confirm. I'll go ahead and select my new resource group I just created. I can automatically, it will also monitor CloudWatch events associated with those resources. And it can also integrate this into Systems Manager Ops Center. So I'll go ahead and click next. And it's going to do some discovery on those instances. So as I mentioned, the Systems Manager agent is already installed on those EC2 instances. So it's starting to get inventory information from them, and is able to kind of guess basically what type of applications are running. So we'll just give this a moment. And what you'll see here is that it's found two components, my two EC2 instances. So it's properly detected that the web app instance, which has IIS on it, that's a front end, and it's detected that my SQL EC2 instance is running a SQL Server database tier. Now, I can also select different tiers, or I can create custom tier, but for the, obviously this session is focused on .NET. So we're going to just stick with the two here that it's automatically discovered. We'll click next. Now on here, on my instance, so I'll just remote desktop into that and show you. Okay, so I'm going to just log in to my web server. I'll go to the file system and show you that I have this app logs folder here. So we're going to also tell this, it's the CloudWatch Application Insights is expected you have application logs somewhere. It obviously doesn't know where, because that can differ from application to application. So I'm going to go ahead and put in my application folder path. It's already detected IIS, and IIS has a standard log path, so let's put that in, as well as the error logs from the database tier. So those, the IIS and the SQL, have been filled in, and it's asked me to provide my application logs. So click next. Everything looks good. We'll hit submit. All right. So now this application in App Insights has been created. It's now monitoring these two components, my SQL Server and my IIS.NET Web front end. And basically in a few minutes, what it's going to do, it's going to start collecting the logs and metrics off these servers. So we'll just give that a second, and then we'll go take a look at those. So I can go into one of these components here. We get more details on the component. I can see what resources, it's monitoring. I can see the application logs. So you'll note here the application log, the IS log, and it's going to put these to these log group names in CloudWatch. It's also collected event logs from the Windows Event Viewer, application, system, and security at these different event levels. And these will be the corresponding log group names that we see in CloudWatch logs when we go to look at those. So let's go ahead and go to the metrics section. You'll see for the web front, these are the type of metrics it's going to collect. So ASP.NET, .NET CLR, these are obviously .NET specific metrics, where if we went back and let's go ahead and look at our SQL component, those logs are obviously going to be different, as well as the metrics. It's going to pull in SQL Server specific metrics here. So again, it's pretty much discovered my application just based off of what it's detected was already installed, and did a lot of the guesswork in terms of the metrics and logs I need to pull to be able to effectively get observability on this application. So as you can see here, we have our log groups. So I can go in and I can look at these individually, and I can go into each of the log streams. A log stream is just a type of dimension or way to segment a log group. So you generally do this by resource. But the easiest way to look at these logs is log insights. So I can come into here. Again, this is a super easy way to search across multiple sets of logs or a specific log. So you can come into here. I'll select a few of these, or all of them actually. I'll just run the simple query here. And it's just going to simply return all of my logs basically over this period of time over the last hour from all those different type of log groups. And I can write more sophisticated queries, filters. I can write regular expressions, that sort of thing here. But it's simply just grabbing all my logs right now. And then on the metrics side, what that's done is it's brought in the metrics under this custom namespace, CW agent. And I'll be able to basically see all my metrics, like the paging, file usage, things for the operating system, things from SQL Server, and then even things from, say, .NET. So these are the type of metrics that you'd find if you went into Windows Perf 1. The CloudWatch agent is, and you'll notice that we didn't actually have to install the CloudWatch agent. The App Insights does that via the SSM agent there. So as long as you have the systems manager or the SSM agent on your machine, the App Insights will basically do the rest here, and we'll start collecting these metrics and logs. So with that, that's the quick overview of how you get started with App Insights. All right, so I've just shown you how to use CloudWatch Application Insights to get started very quickly collecting your metrics and logs, collecting those observability signals. But what if you want to do this yourself, or what if you want to go beyond what App Insights is doing? Right, so we need to go back to again these three fundamental or foundational things for observability: CloudWatch logs, CloudWatch metrics, and X-ray traces here. And we're going to go into logs. There's several different ways to get your logs from your application. You can use our CloudWatch agent, which is what App Insights is doing. There's FireLens. You could call our API, the put log event API. So that's how all logs get into CloudWatch. But there's obviously other mechanisms like the agent, FireLens, or providing a layer of abstraction on top of that. But I'm primarily going to basically show you how you do this with a NuGet package. So we have a series of NuGet packages that you can install in your .NET app, and it's going to simplify how to push your logs directly into CloudWatch logs. So I'll do a quick demo here where I'm going to actually show you how we can use NuGet, a package for nlog, and we can send our logs directly to CloudWatch. So as mentioned, there's a lot of different ways you can collect logs. I've obviously shown you one way with App Insights, where App Insights actually collected metrics and logs just automatically for the most part. And in terms of the custom application log, I just had to tell App Insights where my files were going on the file system, and they just picked that up. And you could definitely still do that. You can start with App Insights. You can go beyond that if you'd like. you can use the CloudWatch agent yourself if you want to. But what I'm going to show you basically is a mechanism to send your logs to CloudWatch using a NuGet package. So we have several NuGet packages for different types of logging frameworks. The one I'm going to show you today is going to be for nlog. Okay, so here is my ASP.NET Core 5.0 web app, and what you'll see here is I have nlog configured. I have my target, and that target is going to the file system under app logs, which is the location we were collecting logs before in the application insights. And it's also basically, it will log anything that the minimum level is trace here, and it will send that. This is our rule basically to go to the app log there. So that's what we currently have set up here. And I'm just doing something pretty simple here, just to log some significant message here. Is when on the index page here, when we visit this, I'm going to cause a divide by zero error in the try catch, and I'm going to then log that message as an error to nlog. And because of how I have nlog set up, it's actually going directly to the. So with nlog, what we do, we have to add a NuGet package here. So that NuGet package is going to be called, I've already added this to my project, is aws.logger.nlog. And you'll find the other log. Actually, I'll just show you right now here. So let's go ahead and manage our NuGet packages. And I'll do AWS logger. And you'll see the different ones that we have, like log4net, for example, ASP.NET Core logging, and then obviously I have the nlog installed here. So I've installed that, and once I've installed the NuGet package, all I need to do at this point is go to my nlog config and add 2 lines. So we're going to add a new target. And so this target is going to be AWS. Type will be, let's do AWS target and log group. So this is going to be the log group name that's used in CloudWatch. So we'll do nlog demo app, follow the same convention we're using there. And then I specify, the region. And let's do US East 1. And we'll go ahead and close that off. And then we'll just simply need a rule here as well, similar to this rule. So we're going to say logger name. And we'll do min level. We'll do trace as well. And we'll write to AWS. And we'll close off that bracket. And what I'm going to do is going to build, and then we'll publish this. And I'm going to go ahead and execute the app a few times, and then what you'll see a new log group show up in CloudWatch logs. So let's go ahead and we'll publish this update. I already have the publish profile set up here. And so I can go ahead and click this and go into, we can look at the individual log stream here. Again, I could query this just like any other log group. But effectively what we've done is we've sub-logging directly in our .NET app using a NuGet package, and it will automatically send those logs to AWS. So with that, I'm going to pass it off to my colleague Amaya, who's going to take you through metrics and tracing.
All right. Quickly reintroducing myself, my name is Imaya. I'm a specialist solution architect focusing on observability. And when it comes to metric collection, there are multiple options for you. There are options for you to directly use the API calls to send metrics, and also you can use the agents or the collectors to collect metrics from your environments without your applications having to make remote HTTP calls to a service like CloudWatch. Now let's take a look at the demo for all of these options.
So let's take a look at the PutMetric Data API implementation. So here I have a console application that actually uses the PutMetric Data API to send metrics to CloudWatch. Here you can see that I've added the NuGet package AWS SDK.CloudWatch in my program.cs. You can see that I'm starting with adding the dimensions. You can add up to 10 dimensions per metric. The way the metrics are organized, if you do not know, is by custom namespaces, and then inside the namespace you can have multiple dimensions, and inside the dimensions you will have metrics and the values for those metrics. So at any given point when you make you can have up to 10 dimensions per metric. In this case I'm using just one dimension. It's called my dimension name 1, and the value for that is my dimension value 1. And here I have the metric datum object, and metric, here's the metric name. Then metric name is demo custom metric. That's the metric I'm sending. And the dimension, if you have more than one dimensions, like I mentioned, you can have up to 10. You can add them as a list here in the to the dimensions property. And here put metric data request object, and you basically specify just the namespace to which you are sending the request to, the metrics to. And here in this, I'm just having an endless while loop. Here I am generating a random number to which I'm assigning the value that is between 1 and 10, the random value generated by this function. It's being assigned as the metric value. And there's a timestamp at which I want the metric data is captured. And here I'm adding that to metric to the metric data in the put metric request object, and you can add up to 20 different metrics at any given point, and up to 150 values per metric in each call. So here this is the call that makes the request, put metric data async, and just making it synchronous by calling the the result property. So here I'm checking the response. If the response is okay, I'm saying they've sent the metric value, and for every 10 seconds this process repeats endlessly. All right. So here you can see that I've been running this executable before, so you can see that the value is being continuously sent. Every 10 seconds you will potentially see this getting updated soon. The value gets updated. So this is a pretty straightforward implementation of how you can send metrics through put metric data API call. Okay, this graphic shows what actually is happening. So you have the EC2 host where you have the .NET application running, and this .NET application is using the AWS SDK to send metrics through put metric data API calls to CloudWatch. It's pretty straightforward. So I'm on the CloudWatch console, and I want to show you how the metrics end up here. So the all metrics, and you can see that I have a namespace called demo custom namespace, and under that I have a dimension called my dimension name 1, which is what we used, and the value is the name of the metric. And here you can see the metrics are being sent. If I go the last 15 minutes or so, you can see the metrics shown here, and this I can change it to 10 seconds, so there can be more random values, which is what we collect. So every 10 seconds. All right, so that's how the put metric data API works. Now let's take a look at how you can use embedded metric format specification to send metrics to CloudWatch. So with using this, all you have to do is, instead of using put metric data API calls, you'd be using put log events API calls, and you will have to use this HTTP header, the specific HTTP header, to send your metric data in the form of log events. And the log event looks in a specific way, and this is the root structure. We'll look at that in detail, but before that, let's look at the code. Here I have a project. It's a console application where I have the code, and to do all of that I mentioned before, we created a NuGet package, the Amazon CloudWatch.emf package, and I'm also going to use the Microsoft extensions.logging NuGet package to collect logs. Like you remember, I talked about you sending metrics in the form of logs. So let's go to the code, and here I have, let's look at the most important factors here. Here the service name, the service type, and all that. But the important thing for you to note is the log group name. So this is the log group under which you will be sending your metrics to. And the endpoint is this, default. For this, you need to have the CloudWatch agent running. I have the CloudWatch agent running locally, and it's listening on this port 25888, to which you can send the metrics to. The SDK automatically does that for you, but you have to configure that here. And here, what I'm doing is I am calling a function called emit metrics, and I have a specific configuration here. The configuration is this, the log group name and all that other details, and the logger factory. So which is what I would use. I just create a logger factory above, and I'm sending that, passing those two as the parameter to the emit metrics function. Inside the emit metric function, I'm adding, creating something called a dimension set, because I can have multiple dimensions. And here I have this dimension called service, an aggregator, and there's another one called region and US East 1. And I'm adding that. So you can add multiple dimension sets to the metrics. And here's the specific metric that I'm collecting called processing latency, and there's another metric called count. There are two metrics that I'm collecting, and I'm adding additional properties as well. So all of these data will go into the log event, just remember that. And you can also collect kind of additional complex data as well. Like in this case, I'm adding collecting more data. It's custom additional property called payload, and inside that I'll have multiple values, so sample time, temperature, pressure, and all that. These are all additional information. So because log events can take a lot of details, you can store a lot of details, and you can actually query them as well in the future. And here's another property called payload that I'm adding, which is basically this data that I'm adding. And I'm just sending the metric. So metrics.flush will send the metric to the CloudWatch agent, and from there the CloudWatch agent will send the metric. So if you look at it, the overall architecture looks like this. So you have the .NET application, you have the CloudWatch agent running outside of the .NET application in the EC2 host, and the metrics are being sent from the application using the EMF SDK to this endpoint locally, and the CloudWatch agent sends put log events API calls or metrics to log events to put log events API calls to CloudWatch, and from there CloudWatch picks it up because it sees that metrics are in EMF format, and also there is this HTTP header, so it knows that those are log events that have metrics inside, and it extracts those metrics and puts them in CloudWatch. All right. Now let's look at how this metric appears on CloudWatch. So here I'm on CloudWatch, and if you remember in the CloudWatch log group, we talked about the demo app log group, which is what we were sending the logs to, and this is the data we are sending. This is the metric data that we are receiving, and you can see the processing latency, milliseconds, and all that from here, and you can see the service and region. Those are the dimensions under which we are collecting, so we added that. And the log group name is demo app. That is also data that comes in. And here are the additional properties that we collected. So these are all the additional properties that you see here. And that's data. So that's log event. So what CloudWatch does is it extracts data out of this log group and sends them to metrics. So if you go to the metrics screen here, and if we go to AWS embedded metrics namespace, and under this there is this dimension under which we are collecting the metrics. So if you can see last 15 minutes, there's been metrics that we've been sending. All right. Okay, so that shows how you can collect metrics using embedded metric format. You can also collect custom metrics from your applications in Prometheus format. So if your application is exposing metrics in Prometheus format, for example, I have an ASP.NET Core application here where I have instrumented this application to expose metrics using Prometheus. In Prometheus format, I use the open source Prometheus NuGet packages here, as you can see, and I've created a couple of metric types or metrics. One a counter type metric, another one gauge type metric. The metric name is sample app ticks total, which is the type of counter which keeps increasing, basically counter types, and gauges are ones that are going that go up and down. And a classic example is a HTTP response time. That's exactly what I'm measuring here, API response time. All right, so here I have these two metrics that my application is exposing, and I'm going to use I'm going to collect these metrics from this endpoints and send them to Amazon CloudWatch and also Amazon Managed Service for Prometheus. I am going to use the AWS distro for OpenTelemetry Collector for this, and as you can see here, let's go through the code here a little bit. So here in the home page in the index action method, anytime that method gets invoked, I'm increasing the counter metric by 1, and then here anytime the invoke API action method is invoked, which is another page that gets displayed here, I'm just simply calling an API gateway where there's a Lambda function behind that API gateway, the response, and I'm measuring the response time by measuring the time, and then basically creating the finding out the latency of how long it takes for me to make the call and then the response to come back, and adding that to the API response gauge metric, and I'm sending that back to the view and then displaying that. So it's pretty sort of straightforward. And I also have another action method where I'm making a call to a DynamoDB table and responding things, but here I'm not doing anything with the metrics, but just so you know that there is another action method as well, which I will make use of in another example later. So now this is the application in action. So if I go here, this is the DynamoDB table, and here this is the invoke API gateway. So you can see that the API response time is displayed here. The API gateway actually responds pretty fast, but it also has a small addition, kind of a randomness to it. Here, this is the API gateway code or the function Lambda function that is sitting behind the API gateway. It can randomly delay the response by roughly 3 seconds. So that's what happens here. If it's if this random number that is generated is greater than 3, then it will delay the task by 3 seconds and only then respond, send the response back. So that happens as well. So what I've done is I have created a couple of functions, a couple of I have just a PowerShell script here that makes the API calls and so we can collect metrics. But let me show you how the metric itself is collected. That is through the configuration here. So this is the AWS distro for OpenTelemetry collector configuration. I have the receiver, which is Prometheus, the receiver Prometheus config here, because the metrics are in Prometheus format, and I'm scraping the local endpoint, the local host 44382, because that is the endpoint. And here, if I go here, if you go to the metrics endpoint, I can see the Prometheus metrics. Here you can see this, and this might be changing based on what the response is like. So this is one, and then this is the other custom metric, and this the other .NET and process metrics. These are all metrics generated by the .NET runtime itself. Okay, so here I have this Prometheus receiver configuration, and I'm exporting this to 2 different places at the same time. So the first place is the AWS Prometheus Remote Write, which is basically the Amazon Managed Service or Prometheus workspace, to which I'm sending these metrics to. And also I'm sending these metrics through embedded metric format or EMF to CloudWatch. So it's very similar to what we saw earlier. Instead of using CloudWatch agent, we are using the AWS distro for OpenTelemetry collector to collect Prometheus metrics and send them as CloudWatch metrics to CloudWatch through EMF. And that's what's happening here. So this is the pipeline. In the pipeline, I'm saying the receiver is Prometheus, and the exporters, I have the AWS Prometheus Remote Write and AWS EMF. So this is the pipeline, and this is what I've used to run the collector. So to run the collector, all I had to do was basically have it installed here. You can run it as a Windows service if you want. You can say config and then say config.yaml, config.yaml. That's the configuration file that I showed you earlier, and then if you run it, it will start collecting the metrics, which is what I have already done here. So that's what we have seen. So this is how it looks like. So here I have the .NET app, which exposes metrics in that /metrics endpoint, and then I have the a.collector, which is reaching out to that endpoint over HTTP. It collects those metrics, and it is sending the metrics through put log events API calls to CloudWatch and the remote write API to Amazon Managed Service for Prometheus. So that is how it works. And now let's go take a look at how the metrics look like in CloudWatch and in Prometheus. All right, I'm on the CloudWatch console, and here I'm going to go to the CloudWatch log groups to which the embedded metric format events are being sent. And here I'm in that MVC app log group. There's one log stream inside because there's one EC2 instance in from where we are collecting metrics, and this is one of the events from where we are collecting the metrics. So you can see there are multiple log events where these metrics are being sent. And if you see, this is very similar to what we saw earlier in the putmetric data API call. So it's very similar. Okay, so now that we have all the metrics here, so or the log events containing metrics here. So let's go take a look at the metrics screen. You can see that in the metrics screen, there is there's the namespace called MVC app, under which we are collecting the metrics. This is a dimension under which the metrics are here, the 2 dimensions essentially, and ignore this one. This is what I was testing. And here instance job, and let me go look at the one that we actually want. This one, this is the one that is, and you can see that there's already one that is graphed, which is basically the same metric from that same API response in the last 30 minutes, and it's going up and down based on what is happening in the Lambda function. So there you go. So that this allowed us to collect metrics into CloudWatch through AWS or OpenTelemetry Collector. So now the OpenTelemetry Collector not only has been configured to send metrics to CloudWatch, but I told you that they are also sending the metrics to Prometheus. And here I have a Grafana dashboard, or I'm in Amazon Managed Grafana, and I am talking to the data source that actually has that has been connected to the workspace where we are collecting the metrics. This is the workspace to which I'm sending the metrics to, and I've configured that, and that is the data source I'm using here. And you can see that the API response is the same type of metric where we have all the data. Okay, so this basically shows how you can collect. You can literally use just one collector, and you can have one application exposing metrics in Prometheus format. You can send to different destinations here. In this case, we saw CloudWatch and Amazon Managed Service.
All right, that was the demo. And now when it comes to trace collection, there's multiple options for you here as well. So you can use the .NET has the .NET Auto Instrumentation Agent, for example, which can automatically collect the traces. And you can also use the Xray SDK for .NET or even the OpenTelemetry SDK for .NET to collect traces from your environment. And you can use multiple collectors like the Xray agent or the AWS distro for OpenTelemetry Collector to collect traces. Now let's take a look at a demo for this.
The AWS distro for OpenTelemetry Collector can also be used to collect traces from your application. For example, in the same application that we saw earlier, I have also configured it to collect traces. So you can see that I'm using the OpenTelemetry library here. And just a reminder, there are many packages here that are not final yet. So this is kind of an early stage situation, so just be aware of that. I'm using OpenTelemetry packages here, but you can also use the Xray SDK, the AWS Xray SDK, to collect traces from the application. The reason why I'm using the OpenTelemetry is because it's new and it's upcoming, and the Xray SDK is something that you might have seen before, so I wanted to show something new. So here I have this OpenTelemetry packages that I've added to my project, and I have done some little bit of configuration here so I can collect traces. So one of the things that you can do is you can automatically collect traces created by the AWS SDK calls you're making, and also HTTP client calls that you're making, or calls that you're making to APIs using HTTP client, which happens to be the most happens to cover most use cases. So here you can see that I have in the configure services method, I've added these two capabilities here. So add AWS instrumentation, then add HTTP client instrumentation. So those are the two features that I'm primarily looking for. And what happens here is with this add OTLP exporter method here, I'm basically configuring the application to export the metrics to my OpenTelemetry Collector at this port. So this is the port at which the traces are being exported to, from where my OpenTelemetry Collector picks it up and sends to the AWS Xray destination. So once I've done that, and I've also kind of named the application as MVC app, and I would see these traces in Xray, AWS Xray, and so on. So if I go to my collector here, you would see that I haven't done not too many things, but you can actually add things to it. So you can actually add additional context information, additional metadata information to the trace data you're collecting, additional subsegments or spans in the OpenTelemetry world, it's called. In the Xray world, it's called segments. You can add that to capture minute activities that you're doing in your application to get much more detail. So this is what you see in this application is pretty straightforward. I've not done anything at all. So simply because I've configured my OpenTelemetry SDK to collect AWS SDK calls and HTTP client calls, it is going to do it's going to track all those calls, and because of that, my DynamoDB calls will be traced, and these calls that I'm making to the grocery table in my DynamoDB will be traced, and all the calls that I'm making to through the API gateway through HTTP client, they all will be traced as well, because I have configured my application to collect those traces. Now let's take a look at the configuration file for the AWS distro for OpenTelemetry Collector. So here earlier we saw the Prometheus receiver only in the metric collection. Now I have also added the OTLP section. The OTLP section, here's the endpoint at which the metrics are being sent to. So this is the endpoint that is configured here, and I'm sorry, I meant the traces. So the traces are being sent to, and here in the exporters I've added the AWS X-ray section, and all I did was just mention the region. If it's the same region that you're sending to, you don't have to. Here I'm sending it to a different region, so I had to configure that. And in the pipelines earlier we only had the metrics pipeline. Now I also have the traces pipeline. So here I'm saying that the traces are being received in the OTLP format, and they need to be exported to AWS X-ray in the format that X-ray can understand. That's what the AWS, the SDK does. So basically the OpenTelemetry extensions, this particular package, that's exactly what it does, these two. Okay, all right. Now that we have it, so what this means is we should be able to see the traces in the AWS console. All right, so I'm on the CloudWatch console. I'm in the X-ray service map, X-ray traces service map screen. You can see that the service map appears here. My application is talking to the DynamoDB table. It's also calling the Lambda function through the API gateway. It's pretty simple, but you can also see that there is this little red indication showing that there is something going on here. The 1% of the requests are faulty. There are some false. We'll look at that in a little bit. I have actually hosted this application on an ECS cluster, and I'm also collecting logs from the application. And in the next section, I'll show you all the additional things that you can that we're able to get from that setup, and what else we can do in terms of identifying the root cause and so on. All right, I have deployed the application on an ECS cluster, and as you can see here, it is deployed and it's running, and that's the endpoint which we can access through the load balancer URL and so on. All right, I also have a couple of scripts that are hitting these endpoints, this one and this one. And this one, if you can query by default, it lists all the apples as items, and you can actually change it to other products with the query. And if you entered a wrong product, it will give an unhandled exception. So this exception is not handled by the application, and it actually returns a 500-ish error from the server. All right, so there are certain requests that I'm making in the script that actually make some wrong queries like this and that cause errors. And now we're going to see how we can make use of the traces, logs, and metrics all together, and see how we can potentially find out the root cause, maybe from the traces, how we go all the way up to the logs and find out what could be the problem. All right, so in the CloudWatch console, in X-ray service map, and I'm here. Let me refresh this. So I got the latest data. There you go. And here it looks like this, and that's the MVC application, grocery, DynamoDB table, and the Lambda function and all that. All right, so you can see that there's a red here, so that basically means there's something going on. So there's a fault, and it's sort of predictable because the faulty requests are being made in a specific sequence. I think it's like 25 seconds or so. And you can always filter, and this is basically the metric. This is the metrics generated from that, right? So that's what it is. So what we can do is we can actually go back here, and we can filter that, and you can see that's the higher percentage. So let's go and view the traces. You can also see here if there are any alerts or anything like that. I can see the response time distribution for the entire the service and all that. But let's go see the traces, and here we have all the traces. And let me take this out and select the service particularly, and add this to the query and run this query. And the last 15 minutes has been 652 traces on this, and in that particular service map, these are all the different services that were involved. And you can see you can actually refine the query by by either the response time distribution or the duration distribution by simply selecting here. But what I'm interested in is I'm interested in those errors that I saw. So there are a lot of 500s, and what I'm interested in is basically taking a look at one of the log events and one of the traces here and see if I could find out which line of the code or what caused that issue, that 500 error. So if I clicked on this trace, and this actually takes me here and it shows that, yeah, there's a problem with the service. I can also change this to sort of icons or metrics, and can actually see the details as well of the response time and so on. And here it shows the response code, and that is the service that's causing an exception. And you can see that in the exception tab, it actually has a message saying sequence contains no elements. The metadata, these are all the metadata captured by the OpenTelemetry SDK. And this is automatically captured. Like I mentioned before, you can always add additional information that you need, and you can also add additional information not only in the form of metadata, but also you can add queryable attributes that into the traces as well. So here you can see that URL also. So this is the URL that was used. So it basically says wrong product, so the product doesn't exist. So here I have the trace ID, and what I want to do is I want to copy this trace ID and actually go click on View in CloudWatch Logs Insights and see if I'm able to find the log for that particular trace, or when the trace was captured. I know that MVC app was the log group, and here you can see that this trace ID is automatically there, and there you go. You have the trace, the log event that has the trace ID. So it basically says the sequence contains no elements, and it seems like it was trying to, it is caused because we're trying to parse a list or trying to make a link query on a list that did not have any elements at all. So that's the source of the error. Okay, so that's a really quick demonstration of what you can make use of, what you can do with the OpenTelemetry collector, the SDK, and traces, logs, and different types of metric collection mechanism and all that. One small piece that I did not mention is about how I was collecting the logs, and I'm simply using the default log forwarder here. So here, if you go to the task definition, here I'm simply using the default log collection mechanism that ECS offers, and you can actually use other mechanisms too. The OpenTelemetry collector, as of today, does not do much with logs, so it is advised to use other mechanisms like FluentBit or FireLens and other things. So if you want to see it clearly, so let's go there, and if you see here in the log collection, in the log section, I'm simply using the AWS log driver, and you can see that there are other options here. You can use FireLens and other third-party log forwarders and so on. So based on what you choose here, your configuration here would change. So that is ECS specific. So let's not dive deep into that at the moment, but that is how I'm collecting logs. All std out is being collected at the moment, and also the code that actually ingests the trace ID and all that is also pretty straightforward. So in the log where I'm actually capturing the data. So here, if I go to the query here, so I have this try catch. So this is exactly where the exception is getting logged. Here I'm trying to run a link query on a sequence that does not have any elements, and that's exactly why I got this exception. I'm handling that, I'm logging it, and I'm basically throwing it again, and that is why you get the 500. So that's why it basically says, okay, something's weird here, and I'm actually logging this, and this is just the default logger, the ASP.logger. I'm not doing anything fancy at all here. That is passed through the controller's constructor, and I have access to it, and that was set up here through the by the pipeline. So I added the logging capability through the pipeline here, and yep, that's the demonstration.
Always remember the basics. Now the summary: metrics, logs, and traces. Those are the three signals that you want to be collecting to observe your application performance and health. And you can set it all up really quickly using CloudWatch application insights. Then you can build up on application insights with more instrumentation using all the different mechanisms that we discussed in the session. And to get all of the hands-on experience of all of these technologies, all of these features, look at Observability Workshop at observability.workshop.aws. So it can give you a full hands-on experience for you. Thank you for participating in the session. It was great talking to you all.